So this part is your cation, but is this your complex part? First, these are few examples like your NH2, Cl minus, Br minus. So this is your amide, this is your chloride, this is your bromide. Now what does O stand for? O stand for your oxidation number. So hello my dear student, how are you all? So I welcome you all to Allen Overseas. So as you already know, we are going to cover 45 topics in your 45 days. And over here you can see the distribution of your 45 topics according to your physics, chemistry and maths. And this is very important for all of those students who are preparing for your JEE mains. So without any delay, let's start with our topic of our chemistry. And the name of the topic is the nomenclature of your coordination compound, obviously which will be from your coordination compound chapter. So firstly, to name the compound, there are few basic terms which we should know. So let's first understand those important terms. Like if this compound is given to me and if I will break them into the ions, they are going to look something like this. So what is this part? So this part is your cation, but is this your complex part? No, that's why we are going to call this as your simple cation. Whereas this over here is your complex anion. Sir, what makes this as our complex anion? As over here you can see, this is actually in this bracket and it contains central atom as well as our ligand. That's why we call this as our complex anion. And because this is your positive charge, that's why this is your cation. This has a negative charge, that's why this is your anion. So these are few important terminologies which we have to keep in mind. Now let's see a few more. Like over here, this compound is present. So when it is present close, like in this situation, they were in the anionic form. But if I will see this compound, then this situation, I can call this as ionization, or you can say ionization sphere. Whereas this is called as your coordination sphere, because this is your coordination part. Now, for your coordination part, like let's focus on to this only, because while naming this part will be more crucial to us. So over here, the first element or atom which you will see, that will be the central atom over here. So this PT over here is your central metal atom. Now after this, whatever compound you see or molecule you see, like your NH3, Cl, all of those are considered as your ligands. And the number, like this NH3 is 4, this Cl is 2. The number, like whenever we are going to add them, the number like 4 and this 2, over here we are going to call them as our coordination number. So these were our few important, what you can say, terms which we have to keep in mind for our coordination compound. Now the next part, which is to name your coordination compound, there are few, what you can say, important things which you should already know. Like we just saw, like your compound has your ligand, that ligand can be your anionic ligand as well as. So if it is your anionic ligand, what is the thing that you have to see? Like ligands which name ends with IDE, ITE, ET. Then just change the last E with O. E with O. This is the basic part, but there are few compounds where we have shortened them. We will see them as well. Okay. So over here, the first, these are few examples like your NH2, Cl minus, Br minus. So this is your amide, this is your chloride, this is your bromide. So to name them, like for your accuracy naming of the ligands, for the anionic part, what actually I am going to name them. So over here you can see there is IDE, IDE, IDE. So instead of E, I can directly write our O, or especially for your chloride and bromide, there are few different names. Let's see them as well as over here. So first of all, your amide become amido, chloride become chlorido, or I can directly write it as chloro. Bromide become bromido or bromo. Now, in a similar fashion, there are few anionic ligands which I have mentioned in the next slide. Just see over here. So, these are few names which we already know. Okay. Now, but this name we are not going to use. Why? They have I, D, E, 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 E present in them. So, instead of E, we are going to replace this E with O, or we will see there what you can say special name over here. So, iodido or ido, cyanide, you can directly write cyano or cyanido. Like over here, this both are correct. Whether you can write this also or this also. Like because they are used very commonly, that's why we have their shorter version also. So sulfido, nitrido, like this is your sulfito, now your acetato, nitrito. Now O nitrito. Okay, so over here if you will see, the most important part is this O, and O. So this was for your anionic ligand. Now let's see the next part, which is your neutral ligand, and these are very important. Why? Because in the previous part we got this idea, like if there is a E, just replace that E with O and we can write their ligand's name. But over here, if you will see, if I will ask you what are you going to name this H2O, many students will get confused. They will say, sir, we can write this as a water. But no, if you will write this as a water, it will be wrong. Because when we are naming our neutral ligand in your coordination compound, we always name our H2O as aqua. Just see. Like this two, I'm going to highlight because especially their two names are little bit different. Like for your H2O, it is your aqua. For NS3, it is amine. But sir, this is amine only. How it is different? And just see over here, what's the different? Instead of 1M, I'm using double M. That's what different over here. Now next NOCO, NO2, I can directly say nitrosyl, then carbonyl, then your nitrile. So these are not that hard. This we know their name. Especially for H2O or NS3, these two special cases are there. Okay. Now once we know this, now we can also see the last part, which is your cationic ligand. So over here, in the RPC naming, just place IUM at the end of the name of the ligand. So this is also not that hard. We can directly add this IUM and we can get the name of our cationic ligand. Like this will be ammonium. Next will be your nitroselium. So this over here, if you will see, only IUM is added. Okay. Now, once we know this part, which is we know the name of our ligands, what's the next thing? Next thing is the naming of the central metal atom, because in this compound there is a ligand, but with this ligand there is one more important thing which is present, which is actually your central atom. And to name the central atom, we are going to change its name depending upon its position. If it is at the cation, its name will be different. If it's at anion, its name is different. Let's see how. So central metal atom is present in the complex cation or complex anion. We have to first see that part. Like in this situation, I can say, sir, this is your complex anion, this is your complex cation. And one more thing which you should know is how to find their oxidation number, because this is a crucial part to name a complex compound. Because if you are not able to find its oxidation number of the central atom, you won't be able to name the compound. That's why it is important. So now to find this, just see, the simple trick is that like if I want to find for Fe, just write it as X. For Cn, I know it is -1. And we just know what's the charge on the bracket, it is -4. So I can directly write X -1 multiplied by how many Cn are there? There are 6, is equal to -4. So X is actually equal to -4 plus 6. What's the oxidation state of your Fe? It is your +2. So the oxidation state of your Fe is actually +2. Now similarly for this, how actually I can write? I can make it as X. And for NS3, do you remember it was neutral? So I can directly write it will be 0. So for X, it will be X plus 0 is equal to +1. So I can write X is actually +1. So over here I can write their oxidation state very easily if I want. So this is your +2 and this is your +1. So like this we can find their oxidation state also. And once like this, once we will name the whole compound over there, you'll understand why it is important. So before that, we have to just see central metal atom in like whether it is present at cation or anion. What is the change of your central atom? Let's see that part. So metal, either they can be like central metal atom can be complex cation or it can be complex anion. So these are few examples. So we know what is Ag. Ag is silver, Fe is iron, Cu is copper, Au is gold, Pb is your lead, Sn is your tin. So like these are the few names which we already know, but if you will see their symbols are different, yes or no? So there, like these are the special compounds which you have to keep their name in mind when you are writing their name in your anion form. Because whenever you are going to write their name in the anion form, especially for this compound, like for Ag it is your argentate, for your Fe it is ferrate, for your Cu it is your cuprate, for your Au it is aurate, for your Pb it is plumbate, for your Sn it is tannate. So over here if you will see there is one thing common, 8, 8, 8, 8, 8 and 8. So these are the actual names which you have to write them, but there are few compounds like their normal name and their old name are same. In that situation, whenever you are going to write, like in that situation, you are going to name the compound what is there for original name, just add 8 over there. Like when we'll do the example over there, you will get this. Okay. So now once we know, like, okay, the name of your central atom will be different when we are naming them as your complex cation and complex anion. So this part we have to keep in mind. So now let's proceed with the naming of your compound. So the first thing that you have to follow is for naming complex ion is LCO or loco. This is a simple rule. Once you know this rule, no, everything will be very easy. What is loco? Let's see that part. So what does L means? L means first name ligands. First, what we are going to name? We are going to name our ligands. And this is also very important. Alphabetical order. Don't forget, like if there are more than one type of the ligand present, in that situation, we are going to name them according to their alphabetical order. So LCO, loco, like this is the naming part of your complex part. Okay. So next part is your L is done. Now C. LC. C means central metal atom name. Now what does O stand for? O stand for your oxidation number. That's why I told you for naming a complex compound, like oxidation number is actually important. So now we have this trick in our mind, LCO. Let's use it. So now in case of more than one ligand, you have to keep this in mind. Like if like more than one ligand is present, obviously there will be more than one. So if it is monodentate, in that situation we will write it as di, tri, tetra. But if it is bidentate, tridentate, or in general if it is your polydentate, we will use a word bis, tris, tetrakis, pentakis, and so on. Okay. So now once we have covered all the important topics, how to name a compound, let's directly jump to an example and let's try to name this compound. So over here, the first thing that you have to keep in mind, you have to find its oxidation state. Like this X you have to find. So what actually I can write over here? I can write over here like there is K, 4. 1K has plus 1. So 4K is going to have plus 4. So if this is having plus 4 over here, cation is having plus 4. So anion should also have your plus 4. So this should be minus 4, opposite of the charge. So in this situation, if I want to find this, this is your minus 1. So what actually I can write? I can write X minus X is equal to minus 4. X will be equal to 6 minus 4, which is equal to plus 2. So over here, I can directly write what is my oxidation state. It is your plus 2. Yes or no? Like this, we can easily find our oxidation state. Now, once we have founded our oxidation state, now the naming is not that hard. What you have to do? Firstly, you have to name whatever present is on your cation side. Always first you are going to name cation part by default, like it is your complex part or not. Like in this situation, your potassium is present and it is not your complex compound. In that situation also, firstly we will name our cation, which is followed by your anion. Okay, so what's your cation? It is your potassium. And how many cation, like how many potassium are there? 4. So should we write tetra potassium? No. Like whenever you are going to name your coordination compound, just write what atom or what kind of element is present without telling how many number are there. Okay, so we'll directly write potassium. So now cation part is done. Now let's see anion part. And as you can see, this is your anion part. So firstly, we are going to use our LCO rule. So firstly, we are going to name our ligand. So what is over here? It is CN. So what's the name of your CN? It is, and how much it is? It is 6. So we are going to use hexacyanide, or cyano also you can directly use. Over here I have just replaced E with O. So you can write hexacyanido. So now once we are done with the cyanido part, what's the next part? So LCO, central atom. So what's the name of your central atom? So you will say iron. In that situation, it will be wrong. Why? Because now it is present on the anion part. In this situation, we have to write it as your ferrate. We have to write it as ferrate, followed with its oxidation number, which should be written in Roman number. You cannot write 2. You are going to write like this, okay, in Roman number. And if you will see, I have only put in a space between your potassium and hexa, not in between them, because the rule says like the space is given only in cation and anion part. Okay, So now once we have done with this example, let's see the next example. So if this example is present over here, the first thing that you have to find is the oxidation state. If this is your X over here, again I can write, like I can directly write this, which is your AgI4 minus 2. If this is your X and this I know will be minus 1, so I can write this as X minus 4 is equal to minus 2. X is equal to minus 2 plus 4. X is actually equal to plus 2. So over here the oxidation state will be your plus 2 in this situation. So if this is your plus 2, so I can directly write this will be potassium, tetraiodido, and Hg, which is mercurate. Oxidation state is 2. So this is how we are going to write our coordination compound name, which is very simple. Now let's take this example, and this is very interesting example. So over here you can see I have used more than one type of ligand. So over here there's chloro also, like there's a chloride, there's H2O, there's NH3. So over here in this situation, first let's write their name only. Like what is their name? There is your chlorido, then there's your H2, which is your aqua, then there's your NH3, which is your, because this is 4 term, that's why I'm going to write tetraamine. Now if you remember, like we are going to use our loco, no problem in this part, but when we are writing our loco, first we have to name our ligands. And now in this situation, if you will see, this is present on your cation part. So firstly we have to name our coordination complex first, but to name this first we have to use the name of the ligands. So over here when we are going to use the name of the ligands, we are going to place them according their alphabetical order. So alphabetical order, your aqua should be there or your tetraamine should be there. You will say, sir, obviously aqua, because over here there is tree. No, whenever we are going to name a like arrange them according to alphabet, so alphabet order, so always see over here this is aqua, and over here we are going to consider amine. So with respect to that, your amine is going to come first. That's why we are going to name the compound as tetraamine aqua chlorido cobalt. Over here you will find the oxidation state will turn out to be plus 3. You have to find this like always. This is very compulsory. So this will be cobalt 3, because we have to write this Roman number. So now we are done with cationic part. What is left with us, which is your chloride. So this will be our last name. So like this, we can name even a very big compound name also. So just like whenever there are more than one type of ligand, place them according to their alphabetical order. So now once we are done with this, let's see, like this is one more interesting type of question which they can ask you, which is cation as well as anion, both are complex. What we are going to do in that situation? Let's see. So over here, the first thing that we are going to do, like this is present. So when we are going to divide them in cation and anion part, they are going to look something like this. So if this is your X and this is your X, we have to find them. How actually we are going to find them? So this is already 0. So I can write X is directly equal to plus 2. So over here I can say the oxidation state is actually plus 2. Yes, and you already know why I'm doing this. For this situation, what actually I can write? I can write X minus 4 is equal to minus 2. X is actually equal to 4 minus 2, which is plus 2 in this situation. So I can write plus 2 over here again. Now when we are like naming this compound, over here both complexes, like both anion and cation part, like this is your cation, this anion, both anion part are actually complex compound. So obviously in both the situation we have to use our loco rule. First we are going to name our ligand. So what's the name of the ligand over here? It is your tetraamine. So we are going to write this as our tetraamine. First we are going to write this as our tetraamine, like this, tetraamine. Now because this is present on your, what you can say, cation part, we will directly write this as platinum and oxidation state plus 2, which is your 2. Now in the second part over here, you will write tetrachlorido or chloro directly, and because this is present on your anion part, so what we are going to write? We are going to write your tetrachlorido, but instead of your platinum, we are going to write it as platinate. This 8 part should be there. Like I told you, whenever we are going to write your central atom name on your what you can say anion part, we will always use this 8 word. Okay. So now we have done with this part. So now let's see a question which is asked in your AIEEE in 2003. What was this question? Just see. So in the coordination compound, this coordination compound is given to us, and they are not asking us to even name the compound. They are directly telling us to find its oxidation state. So like this also, sometimes they ask you, so what's given to us? K4 NiCN4. So I can erase this. I can directly write it as -4 over here. Yes, because it was K4. So it means +4 over here, -4 over here. So I can write this is your X, this is your -1. So what I can write X -1 multiplied by 4 is equal to -4. X is actually equal to -4 plus 4. X is actually equal to 0 in this situation. And we have to see what's the option given to me. First is your 0, second one is your +1, third one is your +2, and fourth one is your -1. So by default, I can correct my first option, which is the correct answer for this question. And you can verify the answer also. The answer is option 1, which is your 0. So now we are done with this question. Let's see the next question. So what is given to us in this question? Let's see. So in this question, if you will see, like this is the reverse part. Like usually you will given the compound and then you are going to name this. But over here, they have already given you with the name. Can you see? The name is already given to you. Over here, you have to find which of the following fits this criteria. So this, like you don't have to follow all, like you don't have to write all the 4 names. You can use a simple trick over here. Like over here, what's the trick? Just see what is given to us in the question. So it is di, like bromido, and bis, like EN, or you can say ethylene diamine. So this should be 2. So firstly, just check. So this option is not correct because this is only given to me as 1. This, now over here, this is given to me as 3. This is also not correct. Now, yes, this can be correct. Let's just verify this. Again, over here, this can't be like true because this ethylene diamide should be 2. So this is also not correct. By default, the correct answer for this question is your option 3. And now we can also verify this also. Dibromido, bis, ethylene diamide, chromium 3 bromido. Like this is in, and also there should be bromide. Okay. So, and when you are writing this as the, what you can say, normal, like not in your ligand form, in that situation, we are not going to use our, we will directly write bromide. Okay. So, the correct answer for your question, this question, which is actually asked in 2012 IEEE exam, is the correct answer is your option 3. So, that's all from my side onto this topic. So, over here you can see answer also. Now over here, as you already know, like over here we are covering our, what you can say, a special series which contain 45 topics in 45 days. You can find whole series playlist in your description box as well as in your comment box. And once you are at the comment box, if you have any doubt or if you have any suggestion for us, you can just comment us or you can ask us. So stay tuned with us. Thank you for being with me.